Okay, graphs and functions, part 4. Before I start, I would like to mention something I did in video part 3, graphs and functions. I said that f of x, when it was minus minus 5x squared, blah, 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 when we said this is the dominant term, which is the term with highest exponent, I said that f of x is negative as x approaches negative infinity, or as x approaches positive infinity. That's true, it's negative, but the question was asking about the behavior of the function. The f of x tends to negative infinity as x approaches minus infinity or plus infinity. Just a little remark I'd like to mention. Let's do this activity. It's find all asymptotes of the function. This function, x squared y equal x squared over x squared minus x minus 2. Okay, first, before finding the asymptotes, we know that if the highest exponent up equal to the highest exponent down, the coefficient of the numerator for the highest term over the coefficient of highest term in the denominator, which is 1 over 1, that will be the horizontal asymptote. But I would just like to do it as limits. It's much better. First, let me factorize the denominator. It's x minus 2 into x minus 1 into x plus 1, sorry. Okay, we factorize it, and then we say we find the limit of f of x as x approaches infinity. As x approaches plus or minus infinity, here is the same, because the function contains highest exponent in the numerator is equal to the highest exponent in the denominator. So it's x approaches plus or minus infinity. We take the highest exponent only in both terms, numerator and denominator, and that would be equal to 1. 1 in this case is y equal 1 is what? Is a horizontal asymptote. So as x approaches infinity, this is the definition of asymptote. As x approaches infinity from the negative side, negative or positive infinity, y approaches, the limit of f of x approaches 1. Y equal 1 is a horizontal asymptote. This means the distance between the curve and y equal 1 tends to 0. It's not 0, so y not equal to 1. Y of the curve cannot be equal to 1. Y equal 1 is a straight line, horizontal line. We draw it as dotted line, and it is called a horizontal asymptote. We are going to see it in another activities when we do activity to sketch the graph. And limit at a point of the function, what critical points we have in the denominator. We have x tends to 2. Okay, we can see when it is tends to 2 minus, when x tends to approaches 2 plus, the same. But here, let's keep it just in 2. When we sketch the graph, we talk about that. That will makes the denominator 0, right? 4 over 0 is infinity, and limit of f of x as x approaches minus 1, also it is equal to 1 over 0, and that is also infinity. In these both cases, the first one gives me x equal 2 is a vertical asymptote, and here x equal minus 1 is a vertical asymptote. And I will do it in another video, in more detailed thing. Okay, we still have time to do some more things. Let's see something about a second derivative, right? Second derivative. The second derivative, we find it in the function to study if the function is concave, the concavity of the function, if it is concave upwards or concave downwards. Let's take this example for example, y equal minus x squared plus 4x, and we need to know if it attains a maximum value or a minimum value without even drawing the table of variation. So what is y prime first? It's minus 2x plus 4, right? And if y prime equals 0, this means x equals minus 4 divided by minus 2, which is 2, right? X equal 2. Let's find the second derivative. Second derivative is equal to minus 2. Since second derivative is negative, then the function opens or concave, let's say. We can say opens downwards, right? Opens downwards, downwards. It looks like something like that, right? It opens downwards. The concavity, since the second derivative is negative, right? Since the second derivative is negative. So what do we have here? We have here maximum point. So the function attains maximum point. We can say maximum value at x equal to, that makes the first derivative equal 0. So if second derivative is negative, then we have maximum point. If second derivative is positive, then it has minimum point. If second derivative equals 0, the second derivative test fails. The second derivative test fails, okay? And we can say that it gives me an inflection point. We are going to see in another example. Let's see this example first. Y equal x squared plus 4x. What is the first derivative? First derivative is 2x plus 4. And if we take it equal to 0, this implies that x should be equal to minus 2. X should be equal to minus 2. It does what? First, we have to find the second derivative. Second derivative is y prime. Okay, we can first derivative, we can write it for sure in the form of dy over dx, right? And second derivative is written in the form d square y over dx squared. All right, this is the definition of the derivative. Second derivative, y double prime, is equal to 2, and it is positive, so it opens upwards, right? It opens upwards like that, and it admits what? A minimum point. Minimum point at x equal minus 2, that point that makes the first derivative equal to 0. Let's see another example. Okay, let's do the example not now, in another video.